Let us now take the concept of higher order linear differential equation. And in that, the first thing is we take the homogeneous. Homogeneous linear differential equation with constant coefficients. So let us take like the general form. Let us take the fourth order. So the fourth order is like this: d4y dx4 plus some constant like say a3 d third derivative of y with respect to x, say plus a2 d square y by dx square plus a1 say dy by dx plus a0 y and equal to 0. So where is a0, a1, a2, a3, these are all constants. So we would like to solve this kind of differential equation. Now here, what we do here is, this is a very good technique here, and it is like this. We consider d by dx as an operator d. So then this becomes like this: d4 say plus a3 d cube plus a2 d square plus a1 d plus a0 y equal to 0. Now, so this is the differential equation that we are having. Now here, we need to solve this kind of differential equation. So here the idea is you make the auxiliary equation. So we also write like this: f of d y equal to 0. And the auxiliary equation is f of d equal to 0, or in other words, you can say that d4 plus a1 d cube plus a2 d square plus a1 d plus a0 equal to 0. Now here, this consider as a polynomial in D. And now you this solve by factorizing. So factorize this into linear factor and then solve it. And after factorizing, we have different kinds of roots. So like we may have the distinct real roots. So if we solve this equation, we may get the distinct real roots, like say M1, M2, M3, M4. This is fourth order differential equation. We'll get four distinct real roots. So in that case, the solution is very easy. All these things comes from theory, but we don't have the proof of this theory. The solution is like this: y equal to some constant c1 e to the power m1x plus some constant c2 e to the power m2x c3 e power m3x plus c4 e power m4x. So, like, if someone asks that solve d square y by dx square minus say 7 dy by dx, then say plus say 12 equal to 0. Then the auxiliary equation here is d square minus 7d 12y plus 12 equal to 0. Factorize this. So we can factorize this like 4 3s are 12 minus, so d minus 3, d minus 4 equal to 0. And so d equal to 3, 4. So distinct real roots. So then you can say that the solution is y equal to c1 e power 3x plus c2 e power 4x. So when we have the distinct real roots, we can have the solution like this. It may also have like equal real roots. We may have equal real roots. So same equation, say fourth order equation, difference auxiliary equation, we may have like this. Say two roots are equal and this M3, M4 are distinct. Then how to write the solution? So the solution is like this: y equal to c1 plus c2x e power m1x plus c3 e power m3x plus c4 e power m4x. It may also like this. Suppose m1 equal to m2 equal to m3. These are three equal roots and fourth root is different. Then also the solution looks like this: y equal to c1 plus c2x plus c3x square e power m1x plus c4 e power m4x. So let us practice here the example like this. Solve, say d square plus 4d plus 4y equal to 0. This d is nothing but d by dx, like this. So what is the auxiliary equation here? So auxiliary equation is d square plus 4d plus 4 equal to 0. And then you can say it is d plus 2 squared equal to 0. And so we have d equal to minus 2 minus 2. So equal roots. So then the solution is yx equal to c1 plus c2x e power minus 2x. You may also have like one pair of complex roots. So one pair of roots complex. So suppose m1 equal to alpha plus I beta, m2 alpha minus I beta, m3 m4. So in this case, the solution is like this: e to the power alpha x c1 cosine beta x plus c2 sine beta x plus c3 e power m3x plus c4 e power m4x. So when you have a complex root, we know it is always in conjugate pairs. Then the solution you can write in this way, like say d square plus 4d plus 3 equal to 0, suppose. So what are the roots here? So let us not take 3, but say suppose 5. So then the roots are like this: d equal to, we know, ax square plus bx plus c equal to 0. The roots are x equal to minus b plus minus root b square minus 4ac divided by 2a. So minus 4 b square, so that is 16 minus 4ac. A is 1 and c is 5, and divided by 2a. A is 1 here, b is 4 and c is 5. So d equal to minus 4 plus minus root 16 minus 20. So minus 4 by 2. So this is minus 4 plus minus 2i by 2. And so we have minus 2 plus minus I. So these are the two complex roots. And so the solution is equal to e power alpha x. Alpha is minus 2 and beta is 1. Alpha plus minus I beta. So e power minus 2x c1 cosine beta is 1 cosine x plus c2 sine beta x. So beta is 1 sine x. So this is the solution. It may also happen that two pairs of complex roots are equal. It may happen that two pairs of complex roots are equal, like m1 m2 is alpha plus I beta. M3 m4 are equal, and that is alpha minus I beta. So then the solution you write in this way, e power alpha x, then c1 plus c2x cosine beta x plus c3 plus c4x sine beta x, like this. Okay, so in the next video we shall solve some more examples. Thank you.